Hello everyone, this is Ryan from High Desert Math Tutor, and today I want to talk to you about adding and subtracting fractions. Now, adding and subtracting fractions is the hardest type of operation you can do with fractions. The reason adding and subtracting fractions is hard is because you have to do a lot more work than you have to if you're multiplying fractions or dividing fractions. So let's jump into a few examples. So say we wanted to add 1/3 plus 1/2. Well, this is saying we have a third of something that we want to put together with half of another thing. Now, before we can add fractions or subtract fractions, we need the bottoms of the fractions to have the same number. So the bottom of the fraction is called the denominator, and the denominator is how many pieces one whole thing is cut into. So right here, something is cut into 3 pieces and we have one of those pieces. This fraction is saying something was cut into 2 pieces and we have one of those pieces. So in order to combine what we have here, we need to cut everything into the same pieces of the same size. So we do this by finding what's called the least common multiple of 3 and 2. And this is how we go about doing that. So finding the, here, let me make a little space. So least common multiple. So let's look at the number 3. So we have 3. 3 times 1 is 3. 3 times 2 is 6. Now, right here, the answers we get when we multiply 3 by a whole number, those are multiples of 3. Similarly, for 2, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And the answers that we get when we multiply 2 by a whole number, those are the multiples of 2. Now what we're looking for is the smallest multiple that both 2 and 3 have in common. And if you notice, 2 times 1 is 2, but 3 times 1 is 3. We don't have a common factor between those two numbers. Well, the next number up for 3 times 2, we get a 6. And we also have 2 times 3, we also get 6. So 6 is a common multiple of 2 and of 3. So here's where we get into some more interesting ideas with math. What we need to do is use the information we've just obtained to transform both of these fractions into what are called equivalent fractions that have a common denominator, which means that the bottom of each fraction is the same. So setting ourselves up for this, we have 1/3 plus 1/2. So my question to you is, what is the only number we can multiply anything by without changing that thing? The answer is 1. So we can multiply anything times 1, and it will not change that thing. So we want to multiply both of these fractions by some version of 1. But notice what I said is a version of 1. That's a very important idea. So let's look at first the fraction 1/3. So we need to ask ourselves, what do we multiply 3 by to get 6? And if we look at our work over here, we multiply 3 by 2. So 3 times 2 is 6. So we have to find a way to integrate that number into being a version of 1. So here's where we see some interesting math. So I think we all would agree that 2 is equal to 2, right? Well, if we use a little bit of algebra, we can divide both sides of this equation by 2. Now I'm going to keep this side the same. So that's going to stay 2 divided by 2. But this side, we're going to actually simplify. Now, what is 2 divided by 2? Remember, anything divided by itself is equal to 1. So 2 divided by 2 is a version of 1. Now, what we can do here is copy over 1/3 plus 1/2. Instead of writing 1 as the simplified version of 1, we're going to write it as the version 2 divided by 2. We're going to multiply 1/3 by 2 divided by 2. Similarly, we need to do this with a special version of 1 that will change the fraction 1/2 into a fraction that has a 6 in the denominator on the bottom of the fraction. So what did we multiply 2 by to get 6? We see over here, we multiplied 2 times 3. So similarly to what we did before, 3 is equal to 3. And if we were to divide both sides of this equation by 3, we'll keep the left side the same. We're just going to put 3 divided by 3. But on the right side, we're going to simplify. 3 divided by 3 is 1. So instead of rewriting this version of 1, we're going to rewrite that as 3 divided by 3. Now we're almost done with this example. So let's go ahead and simplify the multiplication for each of these fractions. So remember, when we multiply fractions, we'll focus on this one first. Remember that we multiply straight across. So what we get is 2 times 1 is 2. 2 times 3 is 6. Now we're going to carry over the addition from right here. And next, this fraction, 3 times 1 is 3, and 3 times 2 is 6. Now that we have a common denominator of 6 for both of these fractions, if we want to, we can actually make that extremely clear, and we can write this as 2 plus 3 has the same denominator, which is 6. And the very last step to this fraction is we're going to add the numerators, the tops of the fractions. So 2 plus 3 is 5, and the denominator still stays 6. So that is our final answer. So this one I went a little bit slow with this example because I wanted to just look at things like the ideas behind how we chose the fraction to be, say right here, 3 over 3. How is that something that we could have come up with? And looking at what allows us to multiply the fraction 1/3 with some other number that doesn't change it. It doesn't change because we're multiplying it by a version of 1. So in the next few examples, we're going to go through the same process mostly, but we're going to speed it up a bit. So let's look at number 2. So 3/4 plus 1/8. So the first thing we need if we're going to add fractions is a common denominator. So we have to find the least common multiple of the denominators, 4 and 8. So let's do it like this. We have 4 times 1 is 4. 8 times 1 is 8. So since 8 is bigger than 4, we can't make 8 smaller, so 4 is not an option. So let's go ahead and say 4 times 2 now. 4 times 2 is 8. So that actually works. Now we have a common denominator of 8. But if we look back at the original fractions, notice this fraction already has 8 in the denominator. So we don't need to actually do anything to that one. But we do need to change 3/4. So what was it that we had to multiply 4 by to get 8? We had to multiply 4 by the number 2. So this will be the last example where we find the version of 1 this way. But we can say 2 is equal to 2. If we divide both sides of this equation by 2, we'll keep 2 divided by 2 on one side of the fraction, but the other side of the fraction will simplify that, and 2 divided by 2 is 1. So what we have here, we have 1 times 3/4 plus 1/8, and this 1 is the same as 2 divided by 2 times, and we have our 3/4 plus 1/8. Now we're going to multiply these fractions. So remember, when we multiply fractions, we multiply straight across. So 2 times 3 is 6. 2 times 4 is 8. Now I'm going to copy over plus 8, or plus 1/8, I'm sorry. Now that we have two fractions with a common denominator, we add the tops of the fractions and the bottom stays the same. So 6 plus 1 is 7. 8 plus 8, or no, I'm sorry, we don't add the denominators. So the denominator stays 8. Whew. Okay, so our final answer is 7/8. Now we're going to look at a couple examples where we subtract fractions. Everything is the same except for the final step. When we add, instead of adding, we're going to subtract. So the first step, let's find our common denominator. So we have 6 and we have 18. So the least common multiple of 6 and 18. Okay, so since 18 is so much larger than 6, let's keep finding larger multiples of 6 until we get all the way up to 18. So 6 times 2 is 12. 6 times 3 is 18. So here we found a common multiple, which is 18. So we're going to go ahead and skip over this step of explicitly showing how we came up with the fractions and that were a multiple of 1, or not multiple, but a version of 1. And we're going to jump straight into looking at what we had to multiply 6 by, which was 3. And we're going to right away just write 3 divided by 3 times 5/6 minus. Now, since the common denominator is 18, and this fraction already has an 18 in the denominator, we're not going to change that denominator. So here we're just going to write 1/18. Now we're going to multiply this fraction. We'll have 3 times 5 is 15. 3 times 6 is 18. And we're going to just copy over minus 1/18. Now, instead of adding, this time we're going to subtract, but we only subtract the numerators, the tops of these fractions. So 15 minus 1 is 14, and the denominator stays the same. Finally, we can simplify this fraction by saying, what two numbers can we multiply to get 14? And we can multiply 2 times 7. And for 18, is there anything we can multiply by 2 to get 18? And we can multiply 2 times 9. Since we have a common factor of 2, or a 2 on the top of the fraction and the bottom, and the operation on the top and the bottom is both multiplication, these 2's cancel out, and all that's left is 7/9. That is our final simplified answer. Now the last example for today is going to be -3/7 plus 1/2. So as before, we need to find the common denominator. So let's look at the least common multiples of 2 and 7. So 2 times 1 is 2. 7 times 1 is 7. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So none of these multiples of 2 are equal to 7. So none of these work. So we're going to have to take 7 to a larger multiple, so 7 times 2 is 14. Now let's keep working our way up with the 2, multiples of 2. So 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. So there, we found a common multiple of 7 and 2. So let's prepare ourselves now to do a little work to convert these fractions over here to equivalent fractions. So just to be extra clear that this is a negative 3/7, I'm going to put that inside of parentheses. Negative 3/7 plus 1/2. Now, what did we have to multiply 7 by to get 14? We had to multiply 7 by 2. So the fraction that we're going to have to multiply negative 3/7 by is 2 divided by 2. Next, what did we have to multiply 2 by to get 14? And we had to multiply 2 by 7. So the fraction we're going to multiply 1/2 by is 7/7. Now, multiplying the first fraction, 2 times 3 is 6. 2 times 7 is 14. But this fraction is positive, this one is negative, so our final answer is negative. Next, I'm going to add the addition sign. 7 times 1 is 7. 7 times 2 is 14. And we have found our equivalent fractions. The very last step now is to add these numbers, the numbers on the tops of the fractions. But if you wanted to be a little extra clear about how to deal with this negative sign, what we could do is move this negative sign specifically to the top of the fraction. Now we have negative 6 plus 7. When you have negative 6, that's like you owing someone 6, and then we're giving them 7. So if you owe someone $6 and you give them 7, what's left over is $1. And the denominators of the fractions stay the same. So we just have 14. So our final answer is 1/14. So if you found this video helpful, please like the video, subscribe to our channel, and if you find yourself needing help with a math problem, feel free to post the problem in the comments below, and I'll make a video going over a similar problem as soon as possible.